Electric current and its effects. Lesson preview. Symbols of components of electric circuit. Circuit diagram. Potential difference. Fuse. Magnetic effect of current. Electromagnets and their uses. Electric bell. You have already studied in the previous class that an unbroken path through which an electric current can flow is called electric circuit. You also know how electric current is generated and how it plays an important part in our lives. The simplest source of an electric current is an electric cell. A simple circuit consists of only a bulb and a cell. However, drawing electric circuits which contain a large number of components is a tedious process, so common electric components are represented by symbols. Symbols of components of an electric circuit. The components such as cells, bulbs, wires, switches, battery, etc. make up an electric circuit. Each of them is represented by a symbol. Serial number. Electric component. Symbol. Description. 1. Electric cell. An electric cell is represented by two vertical lineae along a line and a shorter parallel line. The longer line represents the positive terminal and the shorter line represents the negative terminal. 2. Battery. Battery is a combination of two or more cells. The positive terminal of one cell is connected to the negative terminal of the other cell. 3. Wire. The conducting wires are represented by a straight line. All conductors offer some resistance to the flow of electric current. Copper wires offer very little resistance, and hence they are used to conduct electricity in homes. Other metals like tungsten offer high resistance. Hence, tungsten is used in filaments of bulbs. 4. Electric bulb. An electric bulb contains a filament that glows when the current is provided. If the filament is broken, the bulb stops glowing. It is then said to be fused. 5. Switch in on position. When the 2 points in the switch are connected, the circuit gets closed and switch is said to be in the on position. In this position, current flows through the circuit. 6. Switch in off position. When the 2 points of the switch are not connected, the circuit remains open. The switch is said to be in the off position. In this position, current does not flow through the circuit. Thus, an electric circuit is a continuous conducting path for electric current consisting of a source of electric current, such as an electric cell, and other circuit elements such as a lamp, conducting wires, and a switch. Battery. Many devices like torches, transistors, toys, etc. use batteries. The cells may be placed one after the other connecting negative terminal of one with the positive terminal of the other. A battery of 2 cells. A battery of 4 cells. However, in some of the devices, the cells are not placed one after the other but are placed side by side in a compartment. The cells are connected with the help of a thick wire or a metal strip. The positive terminal of a battery is connected to the negative terminal of the other battery. Spring. Cell. Metal strip. Let us now see how we can connect cells to prepare batteries. We can make a cell holder with the help of a wooden block, 2 iron strips, and rubber bands. The rubber band must hold the metal strip tightly. Cell holders are also available in the market for making batteries of 2 or more cells. Always remember to connect the positive terminal of a cell to the negative terminal of the next cell. A piece of wire is connected to each of the 2 metal clips on the cell holder. A cell holder. Holder for battery of 2 cells. Have you seen a battery used in inverters, cars, trucks, etc.? It has a number of cells in them in series. They are rechargeable. Circuit diagram. We can represent an electrical circuit using symbols for various components as follows. Closed circuit. Open circuit. A diagram which shows the arrangement of various components in an electric circuit with the help of their symbols is called the circuit diagram. The bulb will glow if the switch is turned on and the circuit is closed. The current flows through the circuit instantly. When the switch is turned off, the bulb will not glow as the circuit is incomplete. No current will flow through any part of the circuit. A thin wire called filament present in the bulb glows when the current is passed through it. When the filament is broken, the bulb is said to be fused. Potential difference. If two vessels having water filled up to different levels are connected through a pipe, water flows from the higher level to the lower level until the water levels, and hence the water pressure, are the same in both vessels. If you want to make the water flow continuously, you will need to connect a water pump to the second vessel which continuously pumps water to the first vessel. Here, the water level and the water pressure in the first vessel will always be higher than that in the second vessel. Flow of water. Water pump. In the same way, to make electric current flow continuously, you need a device that can constantly pump current in the same way to create a pressure difference. In electricity, this difference is called the potential difference. So, if electric current flows from point A to point B in a wire conductor, we say that A is at a higher potential than B, or that there is a potential difference between A and B. In an electric cell or battery, the positive terminal is at a higher potential than the negative terminal. When these terminals are connected by a wire conductor, current flows from the positive terminal to the negative terminal. This potential difference across its terminals is maintained in an electric cell till its life expires. Then the current will stop flowing. Note: carry out all the activities under the supervision of the teacher. Activity: take an insulated copper wire. Connect the two ends of the wire, after removing the insulation, at the ends, to the cell as shown in the diagram. Disconnect the two wires after some time, 1 minute, and touch the wire at the two ends. What do you feel? You will feel that the two ends have become hot. Activity: make an electric circuit using an electric cell, bulb, switch, and connecting wires as shown in the figure. Keep the switch in the off position. The bulb does not glow. Touch the bulb. Now put the switch in the on position. The bulb will glow. After 1 minute, put the switch in the off position and touch the bulb. What do you feel? The glass of the bulb gets heated. Activity: take about 7 to 8 meters long nichrome wire and tie it between the nails as shown in the figure. Make a circuit. Keep the switch in on position. Touch the wire after a few seconds. Switch off the current and touch the wire again. What do you observe? The wire gets hot when electric current passes through it. Precaution: while performing these activities, touch the wire only for a moment. When an electric current flows through a wire, a part of the electrical energy is converted into heat energy and the wire gets heated. This is the heating effect of electric current. This heating effect of electric current is used in several appliances which we use at home, like electric iron, electric toaster, electric hair dryer, electric kettle, geyser, and electric oven. These appliances contain a coil of wire called an element. The element heats up when electric current is passed through it. Have you seen the element in a toaster? It becomes red hot and gives off heat. Electric toaster. Electric heater. Lit filament in a bulb. The amount of heat produced in a wire depends on material of the wire, length and thickness of the wire, strength of the electric current. Depending upon the requirement, the wires of different materials and different lengths and thicknesses are used. Long and thin wires offer higher resistance than small and thick wires. The wires used for making electrical circuits do not normally become hot, whereas heating elements of some electrical appliances like a room heater, toaster, etc. get so hot that it is seen as a red glow. Hence, Nichrome is used in the element as it offers large resistance and gets heated when current flows through it. The filament of an electric bulb is made of very thin tungsten wire. It gets heated to such a high temperature that it starts glowing. To reduce wastage in electricity, these days fluorescent tubes and compact fluorescent lamps, CFLs, are available which may be used in place of a bulb. They reduce the amount of heat produced and hence reduce wastage. At times, if a large amount of current is passed through a wire, the wire becomes very hot and it may break or even melt. Fuse. An electric fuse is a safety device in an electric circuit which prevents damage to electrical appliances and possibly fires caused due to excessive flow of current. A fuse is made of wires which melt quickly and break when large electric current is passed through them. In buildings, fuses are inserted in all electrical circuits. The fuse has a special wire, the melting point of which is lower than the metals which are used to make the conducting wires. When excess current flows through the circuit, the fuse wire becomes hot and melts. This creates a gap in the circuit, opens it, and saves the appliance. There are different types of fuses that are used for different purposes. The common symbol used for a fuse is or /. Fuse used in buildings. Cartridge type fuse. Fuse used in electrical appliances. Excessive electric current can be produced if there is improper insulation of wires, and as a result there is direct touching of wires, short circuit. Many devices are connected to a single socket. This causes overload in the circuit. Short circuit and overload of current can cause fires. Nowadays, miniature circuit breakers, MCBs, are being used in place of fuses. These are switches which automatically turn off when there is an overload or short circuit. They can be reset by hand to restore normal circuit. A fuse needs to be replaced after a single use. Activity. To demonstrate how an electric fuse works, set up an electric circuit as shown in the figure. Connect a strand of thin steel wool between two connecting wires. The steel wool will serve as a fuse. Turn the switch on. Touch the steel wool wire. What do you feel? It gets hot and then melts down and breaks the circuit. When heavy current is passed through a wire, having low melting point, it melts to break. This is how a fuse works. Steel wool. Magnetic effect of current. Activity. Electric current produces a magnetic effect. Take a tray from inside a discarded matchbox. Wrap an electric wire around it a few may. Place a small compass in the box. Now connect the free ends of the wire to an electric cell through a switch as shown in the figure. Note the direction in which the compass needle is pointing. With an eye on the compass needle, put the switch in the on position. Do you observe some change? Now put the switch in the off position. What do you see? Repeat the experiment. The compass needle deflects when connected to a circuit and the deflection gets reversed when the switch is in the off position. Increase in the number of coils increases the magnitude of magnetic field. The compass needle is actually a tiny magnet. As you have already studied in the previous class, the needle of the compass points in the north-south direction. The above activity shows that when current flows through the wire, it behaves like a magnet, and the needle of the compass gets deflected. Hans Christian Ørsted, a Danish physicist, in the year 1820, was the first to observe deflection in a compass when current was passed through a wire. This is known as the magnetic effect of electric current. In fact, electric current can be used to produce magnets. Electromagnets. An electromagnet is a coil of insulated wire wound around a piece of a magnetic material, which acts as a magnet only as long as the current is flowing in the wire. The magnetic material around which the coil is wound is called the core. The strength of the magnetic field can be enhanced by using a battery instead of a cell. The electromagnet works only when the current is flowing through it. The strength of the electromagnet depends upon the amount of electric current passing through the coil, the number of turns of the coil. Activity. To make an electromagnet, take an iron nail about 6 to 10 centimeters long. Wind an insulated flexible wire tightly like a coil on the nail. Connect the free ends of the wire to the two terminals of a cell through a switch. Switch on the current. Place some pins near the nail. What do you observe? The nail behaves like a magnet. The pins cling to the nail when electric current flows through it. When the current is switched off, the pins drop as the coil loses its magnetism. Such a coil is called an electromagnet. Note: do not switch on the current for more than a few seconds at a time. The cell will weaken very quickly. Uses of electromagnets. Electromagnets have many practical applications. Electromagnets are used in cranes to pick magnetic material from a junkyard. Doctors use electromagnets to remove small pieces of magnetic material from the eye which accidentally gets in. Electromagnets are used in various electrical appliances like loudspeakers, electric fans, electric bells, electric motors, used in electric fans, refrigerators, AC, etc. Electromagnets are used in data storage devices like hard disks, etc. They are also used in induction cooker, MRI machines, transformers, generators, etc. Electric bell. The electric bell is based on the magnetic effect of electric field. You must have often wondered what makes the doorbell ring. An electric bell has an electromagnet that pulls a strip of iron that causes the hammer to hit the gong and ring the bell. An electric bell consists of two soft iron rods mounted on a non-metallic strip. The connecting wire is wound on the rods like a coil. The coil acts as an electromagnet. The iron strip is connected to a hammer at one end. The other end of the wire is connected to a contact screw through a switch. When the iron strip is in contact with the screw, the current flows through the coil, which becomes an electromagnet. It attracts the hammer towards it. The hammer strikes the gong of the bell to produce a sound. At the same time, the current flowing through the coil stops as the connection between the hammer and the contact screw breaks. Gong, hammer, contact, screw, switch off, battery, metal spring, soft iron core. The coil stops behaving like an electromagnet. It no longer attracts the iron strip. The hammer returns to its original position due to the spring action. The hammer strikes the gong each time the circuit is completed. Remember, buy all electrical appliances including fuse, MCBs, etc. with the ISI mark to ensure that the appliance is safe to use.